Unit 5, Simple Applications of One Variable Calculus. Here 5.1, the curvature. The rate of change of direction, that is the bending of a curve with respect to distance along the curve is called the curvature of the curve at the point. And it is denoted as kappa, the symbol. So remember the rate of change of bending, that is the curvature. So if you see a curve like this, at every point we can draw a circle, and the radius of that circle is the radius of curvature, and the circle is called the circle of curvature. And the point, at that point we can find the curvature of the curve, that is the rate of change of direction. The curvature at each point of a line is defined to be 1 by r, where r is the radius of the oscillating or kissing, we say, that is a touching point. Circle that best approximates the line at the given point. Now, radius of curvature, curvature and radius are reciprocals of each other. Therefore, reciprocal of curvature is radius of curvature, that is rho equal to 1 by kappa. We have formulas for radius of curvature in terms of Cartesian form as well as in implicit form. In Cartesian form, rho equal to 1 plus y1 square the whole power 3 by 2 by y2. We know y1 is the differentiation of y with respect to x, that is dy by dx, and y2 is the second derivative of y with respect to x, that is d square y by dx square. In terms of implicit form, rho equal to fx square plus fy square the whole power 3 by 2 divided by f double x fy square minus 2 into fxy into fx into fy plus f double y into fx square. And you know fx means dou f by dou x, that is partial derivation. Fy means dou f by dou y. F double x is dou square f by dou x square. F xy or fyx, that is dou square f by dou x dou y, or dou square f by dou y dou x, both are same. And f double y equal to dou square f by dou y square, that is differentiating successively f with respect to y. Now you know what is then fx square. Fx square is dou f by dou x the whole square. So don't confuse with f double x and fx square. Fx square is the square of the first derivative of partial derivative of f with respect to x. Similarly, fy square means dou f by dou y the whole square. So don't confuse with f double y and fy square as well as f double x and fx square. Know the difference. Now, center of curvature is x bar comma y bar. It's a point. Center means always a point. So we write in the ordered pair x bar comma y bar, where x bar is x minus y1 into 1 plus y1 square by y2. Y bar equal to y plus 1 plus y1 square by y2. So this factor is common for both. Compare and study. X bar means x minus, here minus comes, here plus comes. Okay. And in x bar we multiply by y1. Here we don't multiply by y1. Compare and study. Now circle of curvature. Normally we know a circle with the center h comma k and radius r means we know the formula x minus h the whole square plus y minus k the whole square equal to r square. This is the formula in normal form. Okay, with respect to curvature, the circle of curvature, we know that x bar y bar is the center of curvature and radius of curvature is rho. Therefore, with respect to that center of curvature and radius of curvature, the formula compared to this formula and you get it. Okay, x minus x bar the whole square plus y minus y bar the whole square equal to rho square. And if a formula is asked, you should define what is x bar, y bar and rho. All these formulas we have to define. Okay. Now let's find the radius of curvature of the curve y equal to e power x at 0, 1. So at every point the curvature differs. So even the curve is same. With respect to the point, the curvature differs. Okay. So a particular point is given. At that point, we need to find the radius of curvature. And sticking to our syllabus radius of curvature, we see only with respect to Cartesian form. So we do the problem by Cartesian form. It can be done by implicit form also if the curve is in the implicit form. Here the curve is in the normal form. So we can do by Cartesian form itself. Okay. So we know rho equal to 1 plus y1 square the whole power 3 by 2 by y2. y1 is dy by dx and y2 is d square y by dx square. So let's find y1, that is differentiate y with respect to x. Here the function is e power x, differentiation is e power x itself. So we get the value of y1 at 0, 1. That means we need to substitute x equal to 0 and y equal to 1. Here there is no y, therefore x equal to 0, that is e power 0, which is 1. Similarly, again differentiate y1 with respect to x. So y2 equal to e power x again. So y2 at 0, 1 is e power 0 and we get 1. It's a simple problem. Therefore, substitute in the formula radius of curvature rho equal to 1 plus y1 is 1 as well as y2 is also 1. So 1 plus 1 square the whole power 3 by 2 by 1. 1 plus 1 square, that is 1 plus 1, which is 2. 2 power 3 by 2 means 2 root 2. So it's a simple problem. You can expect for 2 marks even. Next, find the radius of curvature of the curve x cube plus y cube equal to 3axy at 3a by 2, 3a by 2. This is a point given. And you see this is a curve which is in the implicit form. So as per our syllabus content, we do the problem by Cartesian form. Even if it is more simple if we do by implicit form also. But do by Cartesian form alone. Now consider the given curve x cube plus y cube equal to 3axy. Differentiate with respect to x both sides. So we get x cube means 3x square. Y cube, we don't know, we are doing by normal form differentiation. So we have to consider both x and y as variables. Remember, we are not partially differentiating. We are differentiating with respect to x, y. So here we apply chain rule. So 3y square into then differentiation of y with respect to x is dy by dx, which is y1. So remember, at this point it is important. You should remember to put this y1. Okay, we are applying chain rule. So again I say x cube means we are differentiating with respect to x. So x cube means differentiation is 3x square. Y cube means 3y square into y1. The right hand side 3a is a constant. So xy we use uv. So u dash v, u dash x with respect to x is 1. Y we keep as it is plus then u as it is. So x, y when we differentiate with respect to x, dy by dx, which is y1. So remember these points, okay? Now we collect y1 in one side. So y1 terms are this and this term. So if I take y1 common out, here 3y square, here 3a into x, bringing to the left side 3y square minus 3ax. Okay, the other terms in the right side. So 3ay minus 3x square. Therefore, our y1 is 3ay minus 3x square by 3y square minus 3ax. Making it in a common pattern and cancelling 3 both side numerator and denominator, we get minus of x square minus ay by y square minus ax. I've taken minus common out here in the numerator. So it will look in the same pattern. So our y1 is minus of x square minus ay by y square minus ax. Now we need to find the y1 value at the given point 3a by 2, 3a by 2. So substitute x equal to 3a by 2 as well as y equal to 3a by 2. Our function is x square. So 3a by 2 the whole square is 9a square by 4. And for ay, a into 3a by 2. Similarly, in the denominator also 9a square by 4 minus a into 3a by 2. See, the numerator and denominators are same, so we can cancel both. Okay, this numerator and denominators are same. So minus 1. We are getting y1 at the given point as minus 1. Now we need to differentiate y1 again with respect to x. So our y1 is, remember, this is our y1. So we do by u by v, the whole dash formula. So u by v means v squared, y square minus ax the whole square. U. So here x square minus ay is our u. I consider this there. So consider this one. So our y1 is minus of this, the formula. So consider this function and try differentiating again. So we get v square, that is y square minus ax the whole square. V du, v is y square minus ax, du is differentiating numerator with respect to x. So listen, 2x minus a into, when you differentiate y with respect to x, don't forget to put y1. Okay. So similarly, minus u v dash, u is x square minus ay, v dash is, again here we use chain rule, 2y y1 minus a. So wherever y1 comes, we can replace this minus 1. Okay, now we find the y2 value at the given point. No need of simplifying this these terms. Okay, directly you can substitute the point. So 3a by 2, 3a by 2, at this point we get these factors, that is 9a square by 4 minus 3a square by 2 into this 6a by 2 minus a into, instead of y1 we can substitute minus 1. Okay, and we find here 9a square by 4 minus 3a square by 2 is a common factor in the numerator, and we can cancel that with the denominator. One factor reduces. Okay, the remaining, when we simplify, we get 4a minus of minus 4a by the denominator, one factor, 9a square by 4 minus 3a square by 2. Now this is minus of 8a by the denominator. Simplifying, we get minus 32 by 3a. This is our y2 at the given point. Now we substitute in the formula, rho equal to 1 plus y1 square the whole power 3 by 2 by y2. So 1 plus minus 1 the whole square whole power 3 by 2 by y2 value is minus 32 by 3a, that is 2 root 2. Reciprocating this, minus 3a by 32. Cancelling all the common factors, we get minus 3a by 8 root 2. But radius of curvature is a constant, that is it is a scalar, so we don't consider the negative value. It is a dimension, no? So modulus of rho is 3a by 8 root 2. And in the formula problem, find the radius of curvature of the curve root x plus root y equal to 1 at 1 by 4, 1 by 4. So this problem also we can do by implicit form, and as per our syllabus content, we solve by Cartesian form. Here root x plus root y equal to 1. Let us convert this to the normal y equal to f of x form. It is possible, no? So root y, that is 1 minus root x, squaring. Root y the whole square is y. Right hand side, there are two terms, so we make the whole square. Okay, 1 minus root x the whole square. Now differentiating both sides with respect to x. Y, when we differentiate, we get dy by dx, which is y1. And here we apply the chain rule. First consider x square form. So 2 into 1 minus root x. Then multiply inside the differentiation. So 1 is 0. Minus root x differentiation is 1 by 2 root x. That is, now 2 get cancelled, and root x, when we divide root x, we get root x minus 1 by root x. That is with respect to this minus. Okay, I interchange these two terms. So dividing by root x, we get root x by root x is 1. minus 1 by root x. This is our y1, the function y1, and with respect to the point 1 by 4 comma 1 by 4, substitute x equal to 1 by 4. So 1 minus 1 by root of 1 by 4 is 1 by 2. Reciprocating, we get 1 minus 2. Therefore, our y1 is minus 1. Now y2. Remember, y1 is this one, 1 minus 1 by root x. So differentiating, again with respect to x, we get the first term is 0. So apply chain rule, minus 1 by x differentiation is minus 1 by x square. So minus 1 by root x the whole square into, then differentiation of root x is 1 by 2 root x. Therefore, minus into minus, that is plus 1 by x root x the whole square is x. Here 2 and this root x. Now find the value of y2 at the given point 1 by 4 comma 1 by 4. That is 1 by 2 into 1 by 4. Root of 1 by 4 is 1 by 2. Simplifying, we get y2 equal to 4. Now substitute in the radius of curvature formula, rho equal to 1 plus y1 square, the whole power 3 by 2 by y2. That is 1 plus minus 1. That is y1 is minus 1. Na? So y1 minus 1 the whole square, y2 is 4. So divided by 4. Here 1 plus minus 1 the whole square, the whole power 3 by 2 by 4. That is 2 root 2 by 4. Cancelling, we get rho equal to 1 by root 2. Now consider this problem as a homework. It's similar to the previous problem. Instead of 1, we get a root a, and the point is also a by 4 comma a by 4.